Hello, my name is Christian Cayeros, and my project is called Measuring Lung Capacity. This project tests if height and weight make a difference in the lung volume, vital capacity, and tidal volume of my participants. The reason I am interested in this project and why I conducted this experiment is because I am a biomed student, and we cover pretty much every single bodily system, and the one that really piqued my interest the most was the respiratory system. And this was due to the fact that even though we are all of the same race, we can have different lung volumes. And I was curious on the factors that decide the lung volume. The way that I will test the lung volume of the participants and to determine the factors that that increase or decrease the lung volume is by having the participants breathe into a balloon, and that will test their vital capacity and tidal volume. I'll have them breathe into the balloon 3 times for tidal volume and 3 times for vital capacity. And what tidal volume is basically the participants will take a normal breath and exhale all the air from their normal breath into the balloon. And that is when I will use a meter ruler to measure the diameter and use a chart to reference that so I can make the lung volume. And the vital capacity, I will have the participants inhale the maximum amount of air possible and exhale, and I will do the same process by measuring the diameter and using the chart to measure the lung volume. For this experiment, I believe that individuals who weigh more than others will have a higher lung volume as they have to be able to breathe more to allow more oxygen to reach all of their body, as opposed to having a smaller body, and they would have in turn smaller lung volumes. The control variable for this project is going to be the balloons. All the participants are going to use the same type of balloon, and it's going to be the same size balloons. The the independent variable will be the type of breath that is being taken. There will be the tidal capacity, and I mean the tidal volume and the vital capacity, and the dependent variable will be based off of this. Then it will be the volume of air that is exhaled into the balloon, and this will be measured by a meter stick using centimeters. The resources that I used for this was a bathroom scale, metric ruler, and 20 balloons. To conduct this experiment, I first had to obtain the materials that I stated earlier, measure the height and weight of all 10 participants. Then that is when I measured the tidal volume by having the participants inhale and exhale normally into the balloon. Then I would pinch the end of the balloon and measure its diameter and repeat these steps 3 times so I can get 3 trials for the tidal volume. Then I would do the same thing for the vital capacity by having the participants inhale as much air as they can and forcefully exhaling into the balloon to measure the diameter. Then I repeat this 3 times for all the participants so I can get 3 trials per participant for their vital capacity. Then once I did that, I would use the vital capacity and compare the diameter into the chart that I have in the photo. It'll be the right picture, and that one will show the conversions for the diameter in centimeters to what the corresponding lung volume would be. An interesting observation that I made was that height had the biggest impact on the tidal volume of the participants, as the average volume for the individuals who were taller than average, which was 175.58 centimeters, had on average 741.67 centimeters cubed more than those at below or at average height. Another thing that I observed was that even though I did not test whether the participants were in extracurriculars or sports, I did notice that individuals who did participate in sports did have a much higher lung volume than those who did not participate in the sports. And another observation that I made was that older individuals or older participants had a much higher lung capacity or lung volume than the younger participants. Even though I only had 16 and 17-year-olds, all the 17-year-olds had a higher lung volume than the 16-year-olds. As you can see here, there are my photos. The photo to the left is a diagram of how I measured the balloon. So I had them exhale into the balloon. That'll be for tidal volume and vital capacity. And I would pinch the end of the balloon, and like the picture has it there, I would like put it against the surface, but make sure I would not pressing too hard, and then I would measure it with the meter stick. The tables and the charts correspond with the graphs. So the first two tables are just my first two participants, and the graphs are the corresponding to that and the rest of the participants. I wasn't able to fit every table in there as they took up a lot of space, but the first graph compares the vital capacity and the tidal volume of all the participants, and that'll be the first four graphs to the left. And the four graphs to the right shows the standard deviation and the standard error of my project. The bars actually showed that this project was done very well, and that um, pretty much all of the information that I gathered was in the correct area. The results of this project ended up showing that my hypothesis was incorrect, and that the participants who weighed more than average, which was 73.7 kilograms, had a vital capacity of 508.33 centimeters cubed more than the participants who weighed less than average. And and my results actually showed that height was a bigger factor, as each participant had 741.67 centimeters cubed on average for those who weighed, or for those who were taller or than those who were below or at average height. I believe this should be due to the fact that the people who have taller bodies have, or who are taller, have to breathe in more oxygen to bring like that oxygen to like the rest of their body. And I believe that this was a bigger factor than like the weight, because they get taller as they're growing, and some individuals who like weighed more than others may have gained that weight recently, which would have caused their lungs to just stay the same size instead of growing like the individuals who are taller than the others would have. That is my project complete now. Thank you.